Hi everyone, so welcome to the part 2 of numbers module video. This is part of the snapshot batch that we have started for complete snap preparation. So keep attending this session. In this particular video, we are going to complete the previous session's question and also the remaining concepts, particularly the last digit and factorial concept. So let's begin with the session. Before that, just want to quickly tell you, do check the description for the PDF of both the parts, and towards the end of the PDF you will find the practice questions. So do solve those questions and post your answers or the queries in the comment section. Apart from that, I have also provided the LR session links which I am conducting on Unacademy Learning app. So you can access the links of those sessions from the description, and I'll also update the free sectional test link in the description. As I told you in the previous session that I'm starting a free sectional test series. So you're going to get 6 free sectional tests of SNAP sections, and very soon you will find the link in the description. Right, before we go ahead, this is a bit about myself. In case if you're new to my session, make sure that all of you have joined this Telegram channel. And yes, in case if you haven't watched the previous part video, then you can check the playlist. You will find all the videos over there as part of the snapshot batch series. And keep attending the session at 6 p.m. and 8 p.m. on Unacademy app. Right, so let's continue from the question where we stopped, and this was a tricky question based on the concept of HCF LCM. It looks like a clock question, but yes, it's more of LCM based question. So it says that there are 3 watches, out of which one loses 4 seconds every minute and one gains 4 seconds every minute. If all of them were set at 8 a.m. and an alarm is activated, each watch beeps for a second when the time turns 1 minute in that watch. Now this is the crucial part. Okay, so yes, the slower watch will beep slightly later compared to the normal watch, while the faster clock will beep a little earlier. That's the point. Okay, so the question is, at what time will they beep together for the first time after they were set at 8 a.m. Okay, I have made certain corrections in the option because previously the options that you saw were slightly incorrect, so I have corrected this option. And let me tell you one thing, that this question is slightly different from that LED light flashing HCF LCM question, where you are given a situation that a shop name is displayed by glowing LED, and there are say 4 letters in the name. Each letter flashes after certain seconds, and it remain on for say 1 or 2 seconds, and so on and so forth. So that question is different from this question because in this question, when the alarm beeps, the timer doesn't stop. The clock will continue to count the time further ahead. Okay, so let's see how to tackle this question. So here we have 3 watches. First watch, which is slow, which loses 4 seconds every minute. Second watch, which is the faster one, gains 4 seconds every minute. And the third one, let's assume it's a normal watch. Of course, we are told that. So when the normal watch shows 60 seconds, the first will be showing only 56 seconds because it's slower one, and the faster one will be showing 64 seconds. Now we know that each watch beeps when it completes 60 seconds in as per its own time. So let's understand this lower watch. When will it complete 60 seconds? So when it completes 56 seconds, the actual time is 60 seconds. So when the slower watch completes 60 seconds, let me use different color over here. So when this watch completes 60 seconds, the actual time will be 60 into 60 divided by 56. So this will come out to be what? 450 by 7 seconds. Okay, so we can say that the first watch will blink or will beep after every 450 by 7 seconds. Similarly, the second watch, which is the faster one, so when it completes 64 seconds, the actual time is only 60 seconds. So let's see, when the second watch completes 60 seconds, what's the time in actual watch? So it will be definitely 60 into 60 divided by 64. So definitely this is faster one. So this will come out to be 225 by 4 seconds. So the second watch beeps after every 225 by 4 seconds, and we know the third watch, which is the normal watch, it keeps beeping after every 60 seconds. So all the three will beep at a time which is LCM of this number. So if you just check the numbers, I mean, simply we can find out HCF LCM as 900 seconds, because LCM of LCM of fractions is LCM of numerators divided by HCF of denominators. So 60, 450 and 225, LCM is 900, and denominator 7 and 4, they are co-prime numbers, so HCF has to be 1. So final LCM will come out to be 900 seconds, which is nothing but 15 minutes time. So all the 3 watches will beep at 15 minutes past 8 a.m. So this should be your answer. I really hope you have understood this. Okay, if you have any query, do post it in the comment section below this video. Now let's look at one more question, and this is once again based on HCF LCM divisibility. So three numbers which are co-prime to each other are such that the product of the first two number is 551 and that of the last two number is 1073. Let's assume the numbers are A, B and C. Okay, so yeah, the product of first two number is 551. Okay, and the product of other two number is given as 1073. Now these are slightly awkward numbers, so yeah, we'll have to figure out that which two numbers will multiply to 551. Okay, so we can just try to see by which number is it divisible. So we can just add the digits and we can realize it's not divisible by 3, 5, 7. In fact, if you look at the difference between alternate digit sum, so again not divisible by 11. For 13 we can check manually, so it's not divisible by 13. So let's try for 17 and 19. So when I divide this number by 19, I'll get quotient as 29, right? So this number is definitely divisible by 19. Okay, so 29 into 19 is 551. So we realize that one number is 19 and the other number has to be 29. Now definitely there is one number which is common between these two product. So this 1073 should be either divisible by 19 or 29. So let's see whether it's divisible by 19 or not. So 19 5s are 95, 12, 123 not divisible by 19. Let's check for 29. So if I check over here for 29, yeah, so I'll come to know that 29 3s are 87 and we'll get 30, then 3, right? So this will come out to be 37. Yes, it's completely divisible by 29, right? 1073, yeah, that's divisible by 29. Yeah, so we came to know the three numbers as 19, 29 and 37. So their summation will come out to be 85, isn't that? Now, should you take up this question in actual SNAP exam? That's something that you need to wonder. If you're good at calculations, if you can quickly figure out the numbers, maybe spending say 20-30 seconds over 1 minute should not harm you. But if you get puzzled and if you leave the question incomplete in between after spending 40-50 seconds, then that will be troublesome. So just pick the questions cautiously. Right, now let's understand concept of power cycle that helps us in finding pattern in the last digit. So I have shown something over here. Check this. When I raise any digit to consecutive powers, it produces a pattern in the last digit, and that's nothing but power cycle. So for example, 2 raised to 1 last digit is 2, 2 raised to 2 last digit is 4, 2 raised to 3 last digit is 8, and 2 raised to 4 last digit is 16, that is 6. So once again 2 raised to 5 is 32, last digit is 2, 2 raised to 6 will come over here, 2 raised to 7, 2 raised to 8. So the cycle will keep going on. So I can say the cyclicity or the power cycle of 2 is of 4. That means after every 4 power, the pattern in last digit gets repeated. So the same thing can be depicted like this. So for every digit we can calculate the power cycle, and I have summarized that over here for your quick reference. So you need to remember this. For example, for 2, the cyclicity is of 4, that is power cycle is of 4, because after every 4 power it gets repeated. Okay, and the pattern is 2486, 2486. So you will also have to remember this pattern if you wish to solve this question. Similarly, for 3, the pattern is 3971, 3971. So again it has cyclicity of 4. If you look at 7 and 8, once again they have cyclicity of 4. So digits 2, 3, 7, 8 have cyclicity of 4. And that's the reason you don't find these digits at the end of any perfect square number. I'm sure all of you would have remembered this thing, that a perfect square number never ends with digit 2, 3, 7 or 8. Okay, so here is the reason. Now if you look at digit 4 and 9, they have cyclicity of 2, and all the other digits, that is 0, 1, 5, 6 have cyclicity of 1. Now what does it mean by cyclicity of 1? So if I take any number ending with 6, if I raise to any power, say 35, the last digit will always be 6. So that is what it means by cyclicity of 1. So I really hope you have understood this cyclicity concept. Now let's look at the questions. So these are the kind of questions which are straight away being asked. Remember that whenever you want to find out last digit of any number, you don't need to look at the other digit. So we need to find out last digit for 3 raised to 99. Now we know 3 has cyclicity of 4, right? So what we need to do is we just need to divide this power by 4 and we need to check the remainder. So let me just write it over here. 99 divided by 4, the remainder is 3. Very easy to make out. So our last digit will be equal to 3 raised to 3 ka last digit, that is 7. So answer for this question should be 7, right? Similarly, if I take one more question, this number is 1 lakh and 8, 1 lakh and 8 raised to 12,500. What is the last digit? So this is as good as finding last digit of 8 raised to 12,500. We know this number is completely divisible by 4, right? So last digit has to be equal to 8 raised to 4 ka last digit, and we know 8 cyclicity is 8426, 8426. So last digit has to be 6 in this particular question. Right, now let's look at one more question, and this is slightly different. This is more of a numbers, surds, indices question. So just think about the answer. If you want, you can pause the video over here, because this is a very easy question. So you can always look at left hand side and right hand side, and we can convert them all in the base of 2. So 16 is nothing but 2 raised to 4 whole raised to 1.1. 8 is nothing but 2 cube whole raised to 2.2 into 2 raised to 3 is equal to, say, x into 2 raised to 14. Okay, so if I just check, this power is 4.4, this power is 6.6, and this is 3. So add this power, it will come out to be 2 raised to 14, which is equal to x into 2 raised to 14. Isn't that? So x has to be equal to 1. That's your answer. So this was an easy question. But let's look at another question. Now this question may require some calculation. So you can either write the values. For example, this is 216, this is 625, this is 1000, and then you can subtract 184 out of that, and it will get converted to some power of 7. So that's one way of doing. The other way is using the concept of digital sum. Now what is digital sum? Let's quickly understand this. Guys, for example, if I take two numbers, say 32 into 41. Now what will be 32 into 41? I'm sure you can easily make out. It will be 1280 plus 1. So yeah, right. So 32 into 40 is what? 1280 plus 32. So it will be 1312. Okay, so let me just write 1312 over here. Okay, now just try to find out the digital sum, which is the single digit result for any number. Just keep adding the digits of that number till you get a single digit result. So what is 3 plus 2? It's 5. What is 4 plus 1? It's 5. 5 into 5 is 25. So what is 2 plus 5? 7. Okay, just check the digital sum on the right hand side. So once again it will come out to be 7. So digital sum on the both the sides will be same, right? So we can use this concept over here to quickly solve this question. Now there is one more concept in digital sum which says that if a number is a multiple of 9, okay, the digital sum will always be 9 irrespective of how big that number it is. Okay, so for example 6 cube, we know this is going to be a multiple of 9. 6 cube is nothing but 216. So 216 is nothing but 9. So you don't need to count 9 over here, just ignore 9. 5 raised to 4 is 625. So what is 625? 6 plus 2, 8 plus 5, 13. What is 13? 1 plus 3, 4. So my right hand side is 4. Now I need to get 4 on the left hand side. So 1 plus 8, 9 plus 4, 13. So of course this is 4, right? So this will get cancelled off. So now we need to get 0 as the digital sum. So 10 cube digital sum is 1 minus 7 raised to some power. Okay, so we need to get digital sum 1 over here. Very simple. Now which power of 7 will get you digital sum of 1? So 7 raised to 1 is 7. See, of course you could have solved this question easily, but I wanted to teach you this concept. I wanted you to use this concept. Okay, and that's why I'm explaining in this way. So in case if you are completely not aware of this concept of digital sum, you might be pulling your hair, sir, what you are doing. So what I'll do is I'll also try to provide you the link of this digital sum. If you want, you can watch that video, or you can just type on Google digital sum Ronak Shah. You will find my video where I have explained this concept and its application with much more detail. So you can check that 45-50 minutes video. It's available on YouTube itself. So yeah, this is not 1. 7 raised to 2, it's 49. 49 is 4 plus 9, 13. Or you can just ignore 4. So this will come out to be 4 directly. So this is also not useful for us. 7 cube is 343. Now 3 plus 4 plus 3 is 10. 1 plus 0 is 1. So yeah, it has to be this power. So we'll pick this power 3 as our answer. So I hope you have understood how to use this digital sum. Do check that video in case if you are not aware, otherwise you will end up committing some mistake. Right, guys, as I mentioned, do check the description also. This free sectional tests are for you. So yeah, please make maximum out of this free sectional test. And we have launched this short course of or smaller version of plus subscription, where if you want to access all my quant videos, you can get the plus quant videos, and it will cover 100% quantitative aptitude syllabus for CAT and other entrance exam. So that course price is just 2700. I'll update the link once again in the description very soon. This has been recently launched, so you go for that using code SHART10, and do suggest to your friends also. Now let's understand the factorial numbers. We know what is a factorial number. So for example, 5 factorial is nothing but 1 into 2 into 3 into 4 into 5, right? So we all are aware about this factorial number. This value will come out to be 120. So I'll suggest you to remember all the factorial number till 6 factorial. This will be pretty handy. Just remember this. For example, 6 factorial is 720. 120 into 6. Okay. Now how to find out power of any prime number? Note this word, prime number, not any number. It's just prime number in a factorial number. For example, if I take a factorial number, say 26 factorial, I want to find out power of 2 in this. Okay, what is the maximum power of 2 that will completely divide 26 factorial? It's nothing but finding power of 2 in that factorial number. So what we'll do is we'll divide this 26 by 2 raised to 1, 26 by 2 raised to 2, 26 by 2 raised to 3, and so on and so forth, and we'll write down the quotients over here. So 26 divided by 2 quotient is 13, 26 divided by 4 quotient is what, 6, 26 divided by 8 quotient is 3, just add this quotient. Then 26 divided by 2 raised to 4, so quotient will be 1, because 26 divided by 16 quotient is 1, and remainder is 10. And 26 divided by 2 raised to 5, so can I say quotient will come out to be 0, and for any bigger power of 2 the quotient will come out to be 0. So we need to stop here. So total power of 2 in 26 factorial will be 13 plus 6 19 plus 3 22 plus 1 23. So that's the highest power of 2 that will divide 26 factorial completely, right? Similarly, you can think of you can find out the power of 3 in the same number. Just see whether you are getting the correct answer or not. It's very easy to figure out. For example, 26 divided by 3, it will be 8, 26 divided by 9, it will be 2, and 26 divided by 27, it will not be divisible, so power of 3 will be 10, right? Now in case if I ask to find out power of 6 in 26 factorial, so what I know is 6 is nothing but 2 into 3. So we have 23 power of 2, but we have just 10 power of 3. So how many pairs of 2 and 3 can I make? I can make just 10 pairs. So power of 6 will be equal to 10, right? Similarly, if you are asked to find out number of zeros in 26 factorial, right? So we know that in for example, a number is a multiple of 10, there will be 1 0. If a number is multiple of 100, there will be 2 zeros, and so on and so forth. So basically we need to check for pairs of 2 and 5, because each pair of 2 and 5 will produce 1 0, right? So if for example in some number there are 3 pairs of 2 and 5, definitely that number will have 3 zeros towards the end. So once again, we know that in any factorial number, power of 2 will be pretty more than power of 5. So we just need to check for power of 5. So in 26 factorial, if I want to find out number of zeros, I'll have to find out power of 5. That's the conclusion. Okay. So yeah, once again, it's very simple to find out. 26 divided by 5 is 5. 26 divided by 5 square, that is 25. 26 divided by 25, it's 1. So there will be 6 zeros in this particular factorial number. There will be 6 trailing zeros. Okay, so these are the kind of concepts that will be required to crack SNAP exam. So let's look at some questions. So here is one practice question. What is the greatest power of 5 that exactly divides 30 factorial? Okay, or the other way of asking this question, how many zeros will be there at the end of 30 factorial? So the answer will remain same. Ultimately we need to find out power of 5 only. Okay, so we know 30 divided by 5, it's 6. 30 divided by 5 square, that's 1. So total number of power of 5 will be 7. That's your answer, right? So if you are aware of such concepts, and if this kind of questions are being asked, you can solve such questions in say 15-20 seconds, right? So make sure you're not leaving any concept untouched, because sometimes very simple questions are asked from the area that you have left completely, and then you will regret it. Okay, similarly, this is SNAP 2019 question and we are asked to find out units place digit of this number. Now this is slightly tricky, but we need to know that we need to find out units digit. Okay, and we know one thing, that 5 factorial is 120. So it ends with a 0. Now if I raise to any power, of course the last digit will remain 0. So I don't need to check any number after 5 factorial, right? So we need to just check for 1 factorial raised to 1 factorial, 2 factorial raised to 2 factorial. Now let me just directly write down. So 1 factorial is 1, 2 factorial is 2, 3 factorial raised to 3 factorial. So we can write down this as 1 raised to 1, 2 raised to 2, then 6 raised to 6. Okay, because we know 3 factorial is 6. And then 4 factorial is 24. So 24 raised to 24. Okay, so what is going to be the last digit of this one? 1. What is going to be the last digit over here? It's going to be 4. What is going to be the last digit? So any number ending with 6 will have last digit as 6 only. And what is going to be the last digit over here? So 24 raised to even power. 4 raised to even power, last digit will be 6 once again. So the last digit will come out to be 7 over here. So answer should be 7. So I really hope you have understood this. Yeah, do we have any other question? Right, we have this question. Find the number of zeros at the end of this number. Once again, SNAP question. Okay, so now guys, it's very simple to understand that, for example, if I write something like this, say 50 lakhs, okay, 50 lakhs plus 25,000 plus 550. So how many zeros will be there towards the end of this particular addition? Can I say there will be just one zero? Because this number has just one zero towards the end and then some other non-zero digits. So similarly, this number will have too many zeros, this number will have too many zeros, and so on and so forth. So what we need to check is how many zeros will be there at the end of 5 factorial raised to 5 factorial. So 5 factorial, we know it's 120. So we need to find out number of zeros at the end of 120 raised to 120. Now there is only one zero over here. So, and the power is 120. So total in this number, there will be 120 zeros. It's very simple. For example, if I take a number, say 200 raised to 6, how many zeros will be there? So can I say there are two zeros over here and there is 6 power. So 2 into 6, it's 12. So it will have 12 zeros. So exactly same way, there is just one zero into, so 1 into 120. So there will be 120 zeros. So answer for this question should be 120. So with this, it comes to an end of this particular concept. Now there is one more question, how to solve such question, because sometimes in SNAP they ask you such irrational number based question. So guys, whenever you come across such question, I mean such expression, always try to convert it in this form: a square plus 2ab plus b square, so that you can further write it as a plus b whole square, and then square root of that will be equal to a plus b. So let's see how can we convert the given expression in this form. So our expression is 8 plus 2 root 7. Now once again, this 2 root 7 will become your middle term. So it will be 2 into root 7 into 1. We can write it this way. And this 8 can be written as root 7 ka square plus 1 ka square. So can I say now this is equal to a square plus 2ab plus b square. So this will be root 7 plus 1 whole square. Right, so square root of this will be root 7 plus 1. Right, so in case if you come across such question, make sure that you are solving it. Right, okay, so guys, here is the message from Unacademy. If you are targeting CAT 2023 or 24 or IPMET kind of exam, go for Plus or Iconic subscription for comprehensive preparation. Don't forget to use this code SHAH10 whenever you go for that. Okay, do suggest it to your friends also. These are the pricing plan for your quick reference. So keep learning, guys. And here is the PDF. Here are the practice question, which I'll make it available in the description as the PDF. I have also mentioned the answer options, the correct answer. They are highlighted by red color. Okay, so for example, this is the correct answer. Here just the color is red, but this is not the correct answer. The value which is of red color will be the correct answer. For example, this is the correct answer. Right, so try to solve this question. There are plenty of questions based on whatever we discussed today, and some of the questions are really easy. I'm sure you can easily tackle them. Some questions are slightly tricky, so yes, post your queries and suggestions in the comment section. I'll be reading all your queries. Okay, right guys, so here are plenty of questions. Yeah, now I'll see you tomorrow for the percentage class. Be there till then. Bye bye.